The evolution of IoT connectivity. The future of IoT connectivity promises to be revolutionary. The rollout of 5G networks has already begun, and as these networks expand, they will unlock a new era of IoT possibilities. With significantly higher data transfer speeds, lower latency, and the ability to connect a massive number of devices simultaneously, 5G will enable IoT applications that were previously impractical. In addition to 5G, other communication technologies like low-power wide-area networks will play a significant role in the IoT landscape. Technologies such as LoRaWAN and NB-IoT are designed to provide long-range, low-power connectivity ideal for IoT devices. These technologies are particularly valuable for applications like smart agriculture, where sensors in remote fields need to communicate with a central system efficiently. Furthermore, satellite-based IoT connectivity is emerging as a game-changer for remote and global applications. Satellite IoT networks can provide coverage in remote areas where traditional cellular networks are unavailable. This has implications for industries like maritime, agriculture, and environmental monitoring. Edge computing and IoT. Edge computing is set to reshape the IoT landscape by bringing processing power closer to where data is generated. In the future, IoT devices will not solely rely on sending data to centralized cloud servers for processing. Instead, they will have edge computing capabilities that enable real-time decision-making and local data processing. This shift towards edge computing is critical for applications that require low latency and immediate responses. For example, autonomous vehicles must make split-second decisions, and edge computing allows them to process sensor data locally to avoid accidents. Additionally, edge computing can significantly reduce the volume of data that needs to be sent to the cloud, which is especially important in scenarios with limited bandwidth or strict data privacy requirements. This shift will redefine how we architect IoT systems, with an emphasis on distributed processing, local intelligence, and efficient use of resources. AI and machine learning in IoT. One of the most transformative aspects of the future of IoT is the integration of artificial intelligence and machine learning technologies. IoT devices will increasingly leverage these capabilities to make sense of the vast amounts of data they collect. In the context of IoT, AI and ML can deliver several critical advantages. They enable devices to detect patterns, anomalies, and trends in data, providing valuable insights for decision-making. For example, in industrial IoT, AI-driven predictive maintenance can anticipate equipment failures based on sensor data, allowing maintenance teams to intervene before costly breakdowns occur. AI and machine learning in IoT. One of the most transformative aspects of the future of IoT is the integration of artificial intelligence and machine learning technologies. IoT devices will increasingly leverage these capabilities to make sense of the vast amounts of data they collect. In the context of IoT, AI and ML can deliver several critical advantages. They enable devices to detect patterns, anomalies, and trends in data, providing valuable insights for decision-making. For example, in industrial IoT, AI-driven predictive maintenance can anticipate equipment failures based on sensor data, allowing maintenance teams to intervene before costly breakdowns occur. In the healthcare sector, IoT devices equipped with AI and ML algorithms can assist in diagnosing medical conditions. For example, wearable devices can monitor vital signs and use AI to detect irregularities in heart rhythms or breathing patterns, alerting individuals and healthcare providers to potential issues. Moreover, AI can optimize resource utilization in IoT systems. For instance, in smart buildings, AI-powered energy management systems can adjust heating, cooling, and lighting based on occupancy patterns and weather forecasts, leading to substantial energy savings. In the future, AI and ML will become integral to IoT devices and platforms, enhancing their ability to learn from data, adapt to changing environments, and make informed decisions. The synergy between IoT and ML holds immense potential for revolutionizing industries, improving efficiency, and creating new opportunities for innovation. Security and privacy in the future of IoT. As the IoT ecosystem continues to expand, security and privacy will be paramount concerns. The growing number of interconnected devices presents a larger attack surface for cyber threats. Ensuring the confidentiality, integrity, and availability of data in IoT systems will be of utmost importance. Future IoT security will rely on several key strategies. Device authentication. Strong authentication mechanisms will be essential to ensure that only authorized devices can connect to IoT networks. This will involve the use of secure credentials and robust encryption. Secure communication. IoT devices will need to communicate securely over the network. This includes implementing protocols like Transport Layer Security (TLS) to encrypt data in transit. Firmware and software updates. Manufacturers must provide a mechanism for updating device firmware and software to patch vulnerabilities and address security issues promptly. Security by design. Security considerations should be integrated into the design and development of IoT devices from the outset. This includes threat modeling, risk assessments, and adherence to security best practices. User privacy. IoT devices often collect sensitive data, and user privacy must be respected. Clear consent mechanisms and transparent data usage policies are essential. In addition to these security measures, blockchain technology may play a role in enhancing the security of IoT networks. Blockchain's decentralized and tamper-resistant nature can help verify the authenticity of transactions and data within the IoT ecosystem. Regulatory bodies will likely play a crucial role in shaping the security and privacy landscape of IoT. As the technology matures, we can expect to see stricter regulations and standards governing IoT security and data privacy, aiming to protect both consumers and organizations. Smart cities and IoT. The concept of smart cities is central to the future of IoT. As urbanization continues to grow, cities face numerous challenges, from traffic congestion and pollution to efficient resource management. IoT technologies are poised to address these challenges and transform urban environments into more sustainable, efficient, and livable spaces. One of the primary applications of IoT in smart cities is traffic management. Sensors embedded in roadways and infrastructure can monitor traffic flow and congestion in real time. This data can be used to optimize traffic signals, reroute vehicles, and reduce congestion, ultimately improving commute times and air quality. IoT can also play a vital role in energy management within smart cities. Smart grids, enabled by IoT sensors and devices, can efficiently distribute electricity, reducing waste and the risk of blackouts. Additionally, smart buildings equipped with IoT systems can adjust lighting, heating, and cooling based on occupancy patterns, contributing to energy savings. Environmental monitoring is another critical aspect of smart cities. IoT sensors can measure air quality, detect pollutants, and monitor weather conditions. This data can be used to issue public health alerts and inform city planning decisions. Furthermore, public safety can be enhanced through IoT in smart cities. Surveillance cameras, emergency response systems, and IoT-enabled wearable devices can help law enforcement and emergency services respond more effectively to incidents. Urban planning itself will benefit from IoT technologies. City planners can use data from IoT sensors to make informed decisions about infrastructure development, public transportation, and green spaces, ultimately creating more sustainable and enjoyable urban environments. Environmental monitoring with IoT. IoT has a crucial role to play in environmental monitoring and conservation. As the world faces environmental challenges such as climate change, air and water pollution, and biodiversity loss, IoT sensors and devices can provide valuable data for informed decision-making and mitigation efforts. Air quality monitoring is a prime example of IoT's impact on environmental monitoring. Sensors can measure levels of pollutants, particulate matter, and greenhouse gases in real time. This data is instrumental in assessing air quality in urban areas and industrial zones, identifying pollution sources, and implementing policies to reduce emissions. Water quality monitoring is equally vital, particularly for ensuring the safety of drinking water and protecting aquatic ecosystems. IoT sensors can continuously measure parameters such as pH, turbidity, and the presence of contaminants in water bodies. This information is critical for managing water resources, detecting pollution incidents, and safeguarding aquatic life. Weather monitoring with IoT sensors is fundamental for understanding climate patterns, predicting extreme weather events, and managing water resources effectively. Data from weather sensors can help improve disaster preparedness and response, allowing communities to better withstand the impacts of natural disasters. IoT-enabled wildlife tracking is essential for biodiversity conservation. Researchers can attach GPS and sensor-equipped collars to animals to monitor their movements, behavior, and health. This information is used for species conservation, protection of migratory routes, and understanding the ecological impact of climate change. In conclusion, the future of the Internet of Things is a world that is more connected, efficient, and intelligent than ever before. IoT technologies will continue to shape our lives, industries, and the way we interact with the world around us. Connectivity will be at the core of IoT's evolution, with advanced networks like 5G and LoopWins enabling faster data exchange and real-time communication. Edge computing will make IoT systems more responsive and autonomous, while AI and ML will enhance their ability to make sense of data and make intelligent decisions. Security and privacy will remain paramount, with regulations and standards evolving to address these concerns. IoT will continue to transform industries such as healthcare, agriculture, and manufacturing, optimizing processes and improving quality of life. Smart cities will leverage IoT to enhance urban living, while environmental monitoring will help address pressing ecological challenges. The future of IoT is bright, promising innovation, efficiency, and a more connected world. As the IoT ecosystem grows and diversifies, collaboration and standardization will be key to its success. The convergence of technologies and industries will open up new opportunities, while security and privacy will remain fundamental to its responsible growth. The future of IoT is a world where technology seamlessly integrates with our lives, making them safer, more convenient, and more sustainable. It is a future of endless possibilities and transformations, and it is already upon us.